Hello, everyone. I think we'll get started. Sorry, we're a couple of minutes late this week. It was unavoidable, unfortunately. Uh, yeah, as I remember, I've just had a look, and I think we left the work last week. We were sort of part of the way through this valve that we were modelling up. So we were looking at using the revolve tool, and we were working from uh, this engineering drawing here. So we'd kind of created the majority of the shape of this thing, and we were just about to start putting some of the sort of finishing features on. So we've got I think I said we were going to create this sort of entrance to the valve using the chamfer tool. And then we've got these tiny little chamfers that just knock the edges of the sort of 90-degree transitions off. So it says there's 7 of them here at point 1. So we've got to make an assumption as to where they are. And then the final thing that we were going to do, we were going to cut these fluid paths out. So yeah, the intention of this was it was kind of a valve, part of a valve body, and the fluid either runs in or out through these little cut throughs. So we're going to do those as an extruded cut and then pattern them. So I think if you didn't save that, I think I did say save it. You can always watch along, or if you can quickly model that up, if you're sort of skilled enough to just quickly get that modeled up in the background. But yeah, you can watch mine because I did save it at the end of what we did last week. So we did that revolve. We put a lot of tolerance dimensions into that revolve, so you can see when I click on the revolve there, all those tolerance dimensions are visible. So we put some plus or minus tolerance as on some of these diameters. And again, we were just trying to get it as near as possible to the actual engineering drawing that we were working with. So yeah, my intention for today is get that complete, which shouldn't take us long. We've done most of the work on that now. Take a save of that. And if people haven't got that save from last week, at that point when I complete mine, I'll quickly upload a copy of it, just in case you need it. And then I want to at least create a reasonable approximation of this drawing that we're looking at now as well. Because I think it would be wise to, as we go through and do some of these exercises going forward, we just get into the habit of just really quickly kind of banging out these engineering drawings to a reasonable quality. Because I always feel in previous years that creating the drawings portion of the work seems like an afterthought. So I'm keen to get us into that really sort of early on, and it means that we should be really quick at producing reasonable quality drawings. I think we'll stop short of actually creating a real sheet format. So you can see this sheet format isn't one of the standard sheet formats that are available in SolidWorks. This is an actual custom one that's been designed for a specific company. So I don't think we'll do that, but we'll certainly do the layout of the views. We'll talk about importing tolerance dimensions, which is one of the sort of unique things on this that it's worth learning how to do. So you can see those tolerance dimensions are on the drawing as well. And what we'll do is we'll just pull them straight through from the part file. We won't have to actually define them again. So yeah, that's my intention. Do that to begin with. That shouldn't take us the whole lesson. And then probably have another little practice from some content that I was doing with one of my other groups yesterday, which is this simple drawing as well, which again gives us a bit of practice just modeling things up. It's not a particularly complex model. It uses some of the tools that hopefully a lot of you have used before. I think when I asked the other week, are people familiar with SolidWorks? they seem to be a resounding yes. So we should be quickly. Someone's just asking. I'm just getting the chat window up because it was hiding behind one of my other windows. Is this part of our assignment or just learning SolidWorks? This is all just learning SolidWorks. So yeah, don't worry about the assignment. I think I'll sort of bring all the details of the assignment next week. I tend to release it about week 3, so you've got plenty of time to sort of think about it. But yeah, these are all relevant skills for your assignment. But no, this isn't it. But it will involve a certain amount of engineering drawing creation. So this is all good practice for it. So yeah. And the other thing is, there's a lot of relevant stuff in these 2 videos in terms of engineering drawings. These 2 videos that I made last year, yeah, they're both on YouTube, so you can sort of skip through them or play them at double speed or slow them down or whatever. But there's about an hour's worth in each one of those. But you can quickly just skip through and see what I'm doing at any given point. So yeah, everything that we're going to go through, if you need to dip back into it as you're getting towards the end of your assignment, towards the handing date, yeah, they're quite useful to refer back to. And there's other videos, there's things to do with simulation that we're going to get into probably not next week, but the week after. I think we'll start looking at a little bit of simulation. Mixed with, as I've said, I'm going to try and sprinkle sort of drawing skills all the way through on this one, and we'll not have a heavy load of weeks just doing drawings. We'll just sort of sprinkle them in as we're going along, just so we get those skills up. Right, okay, back to what we were going to do today, which is this one. So I'll keep that as I normally do, just off screen, and I'll bring it back on as and when we need it. But essentially, I'm just going to get the chamfer tool out. I'm going to put that big chamfer on the mouth of the valve, and then I'm going to put some little chamfers in what I interpret as these 7 corners that have been annotated on this drawing. So I'll just pull that over to one side. I'll just get it so I can see it. So putting chamfers on, if you didn't know already, it's a really simple tool. It's more like a sort of point and shoot tool rather than an extrude style, create a sketch and then create the feature from the sketch. So extrudes, revolves, a lot of these features over on the left here on the features toolbar, sweeps, lofts, boundary boss bases, and all their negative sort of counterparts, so all the ones that end in the word cut, all tend you to have to create a sketch first. So there's kind of a workflow that you have to go through to get the feature created. So the fillet feature and the chamfer feature and a few of the others that we're going to apply, they're more what I'd term sort of point and shoot or point and click features, where you just kind of point at a piece of your model and then just turn the feature on. And there's minimal input. So the chamfer feature, all it's going to ask us is, what edge do you want to apply it to? So it's going to be this front edge here. And what sort of scale do you want the chamfer to be? And that's about it, really. There's a few other little tweaks in there, but in terms of creating a basic chamfer feature, it's a very simple tool to actually use. And the tool, or the button that activates the tool, isn't sort of resident in this toolbar along the top normally. It's actually hidden away underneath the fillet tool there. So if you click on that little drop down, we kind of talked the other week, if anything's got a little drop down arrow at the side of it, there tends to be a sub menu hidden below it that's got various other options. But we're not going to use that. That's sort of the most inefficient way of activating the chamfer tool. The best way is just click on an edge on your model, and of the icons that pop up, the chamfer tool is that last one. So that's a lot more efficient use of your clicks and mouse travel, and that's why they've designed SolidWorks in these more recent versions of SolidWorks to actually work like that. So yeah, it gives you a pop-up menu. You've got the chamfer tool on there. When you click it, you should get a preview. Now, I'm not getting a preview because the scale of that chamfer, which is set at 10 mil currently, It's way too big for this part. This part's a tiny little, almost like watch scale engineering. So the sorts of like cogs and mechanisms that you get inside a watch, it's that sort of scale. So 10 mil is way too big. So what we're going to set this at, it's 3 mil in the actual drawing. So if you want to just enter 3 mil in this distance entry box across on the right hand side, of course, again, if you wanted to save mouse travel, which it's always good to do, you could just double click on the 10 mil over here in the actual graphics window itself. It doesn't really matter. You can edit it at either point. So if you double click on that, you can just overtype with 3 and then press enter. And then you should be looking at a preview that looks something like that, which appears about the right sort of scale for us. It looks like the drawing that I'm sort of looking at on the other screen. If you're not seeing the preview, it might be that you've got no preview selected there. So if you want to put it on full preview, you should be looking at what I'm looking at. A few other options which aren't really relevant to us on this particular part, but it's worth knowing that they're there. You can change the angle of the chamfer. So it defaults to 45, which obviously the depth of the chamfer horizontally is then equal to the sort of, I don't know, height of it vertically as we're looking at it. But if you want to change that angle, you can. So if you roll that angle upwards a bit, you can see the effect that you're having. You can also flip the sense of that angle. So at the moment, my chamfer is getting deeper into the part, but if I click on flip, it sort of reverses where that 58 is being measured from. So in one instance, it's being measured from this flat front face, and then in the other instance, it's being measured from the surface of that sort of inside cylinder that represents the hull. So yeah, you can flip the direction. But when you've got it set at 45 degrees, as we're going to set it, it doesn't really matter. The flip direction doesn't do anything then, because obviously 45 is just halfway between the two. So when you've got it like that, click on the green tick and it will OK that feature. And you can see it's been added. It's been added to the model. It's been added into the design manager. And then if you want to go back into it, just select it over here on the left, click on edit feature, and you drop back in to the actual setup menu that you were just using to create it. So let's put the other ones on. So what's the first edge that we're going to apply these to? I think we'll click on this back edge here and then activate it again. So we're creating these little ones as a separate feature so that we can control their size separately to that big first one. Essentially, they represent just as these parts are turned on a lathe, it's just these sharp edges are just knocked off, so it doesn't cut anyone as they handle it. So there, and I think it's also because an O-ring sits in this groove here. So if you were to slide an O-ring over this edge here and it was razor sharp, it would put a little nick in the O-ring and then this thing would leak. So you always have to sort of bear these things in mind when you're designing these parts that are going to have rubber O-rings that fit with them. So we'll change that to 0.1 and we should get our preview. So that's one edge, two edges, 3, 4, 5, and possibly 6. I'm struggling to figure out where the 7th is. Oh, it's probably this internal one there. So yeah, that's your 7. But don't worry if you've missed one out there. It's not super critical. I'm just showing you the concept of using the chamfer tool. So I've got 7 edges. If I click on one of these in error, I can just find it in this list, right click on it and go delete and it'll get rid of it. So yeah, don't worry if you select one and you didn't mean to. I'm struggling figuring out which one I've just got rid of. Oh, it's this back one. So it's that one there, that one. And then when you're happy with that, click on OK and it will insert all those. So there's only one real sort of area that we haven't tackled, which is these slot-shaped cut-throughs that actually cut through that portion of the, I suppose you call it the stem of this valve part. So what are we going to do? We need to make the base planes visible. So I've got them set to invisible at the moment. And I just did that just crudely by clicking on that hide everything icon at the top. So we'll click on that to make them visible again. If when you saved it they were visible, you won't need to do that. Or if yours still aren't visible when you've clicked that, you might have to go into the drop down menu and start playing around with the visibilities of individual types of planes there. But there's a few options there to make them visible because we need them visible now. So let's get our reference back and just have a quick look what we're trying to do. So you can see there's 4 of these cutouts. You could argue there's actually 2 cutouts and they go in twin directions. But no, I'm just thinking out loud there of how we were going to do them. I think how we'll do them is we'll cut a single one out first. So it's going to be an extruded cut, this. And we'll create this sort of slot shape sketch on one of the base planes. So I think we'll create it in our model on the right plane there. And then we'll send it in a single direction away from that plane through to the next surface that it encounters. So it'll be this surface here, this cylindrical surface, and then it'll stop. And then what we'll do is we'll do a pattern and we'll tell the pattern that we want it to rotate around the center axis of our main body here. So yeah, that's the plan. So let's get that going now. So we'll click on extruded cut because I've already said we're going to create that initial feature as an extruded cut. So if you click on extruded cut up there, system, as it always does, it says what plane or flat face do you want to sketch on to create this sketch. So I've already said we're going to select that right plane. When we click on it, so you'll notice there, because I had another session with another group yesterday, we talked about setting up the system to automatically rotate your view round on every sketch that you created. So you saw there, my view rotated round so I was looking normal to the sketch. So I'll just quickly quit out of what I'm doing here and I'll show you how to set that on your systems. So this will work if you're working on your own local copy and you've downloaded it, but I don't think it'll work if you set it on the virtual desktop, if you're logging in through the virtual desktop into university systems. So yeah, this will be relevant for some people, but not for others. So I'm going to temporarily quit out of that sketch. I don't want to begin creating that feature just yet. So I'm going to click on the red X there because I haven't created anything anyway, so we're not losing anything. So I want to discard whatever I've done, which is nothing at this point. And I'm just back in the modeling environment now. I've not got anything selected up here. And then I'm going to go into the tools menu at the top. In fact, there's an easy way to do this. That cog icon on the top menu bar there. I think it should be the last icon that you see. So if you click on that, it takes you into the system options for SolidWorks. And even though there's a sort of bewildering array of submenus down here, which if you're not familiar with them, instantly put you off and you think, cancel, no, I don't know what I'm doing there. There's a really useful sort of way of, you don't even have to remember which menu the option that you want is in. You just have to know some sort of keyword about the option that you're looking for. And our keyword is going to be normal, because I've already said the system refers to this behavior as looking at the sketch normal to the plane. So if we just start typing normal in this search box up here, and you only really have to get sort of 4 letters in, and it's narrowed down all these options to 3 possible ones. And if you read them, it should be fairly obvious which one it is. It's that one. It's the middle one. It's the only one that refers to sketching. So you can see it's a subsection of sketch. And if you read the description, it's exactly what we want. Auto rotate view normal to sketch plane on sketch, and then it should say creation at the end, but it's just been cut off slightly. So if I click on that, it navigates exactly to where that option is. It's in there. There it is. I've got it selected as on currently, and that's what you want as well. So you want to switch that on. And then hopefully, as I say, If you're running your own local copy, it'll keep that switched on all the time now until you come back in here and want to switch it off. So yeah, if you click on OK at that point, now if we go to create our sketch, so let's go cut extrude. What plane do we want to sketch on? That right plane, and then it should auto rotate. Now for people that can't put it in there, there's always that auto rotate option or that view normal to option that's in that view orientation menu there. It's just there. Or if you can remember, it tells you there it's control and the number 8 key. So, but I always forget that. So, yeah. Anyway, back to what we were doing. We're going to create this slot shape. So I think we've used the slot tool before. We may have done, we may not. I'm fairly sure we have. So we want to place a slot with the center point of the slot locked to this horizontal plane that we're looking at edge on there. So of the various slot tools that are available to us, the center point one is the one that we want, because we want a little dot in the center of the sketch, so we can use that dot to stick to that plane or to put a relation, a coincident relation between the two. So center point slot, first click is going to drop that center point. So if you just hover over that plane till it highlights and you get that little yellow coincident relation appearing, and then click. So that's been locked onto the plane. We want it to be vertical, this slot. So again, when you get near vertical, you get that vertical relation icon sort of being offered in yellow color. And when you get it, just click, and the line will now be locked to always be vertical. And then if you drag out to the side, somewhere about there, doesn't really matter too much. And there's your slot. And then we don't want the slot tool anymore. So I'm just going to hit the escape key to get out of that. Just have a look at what I've got, check that I have got the relations on it that I thought I had. Yeah, I've got a coincident one there between the center point and that plane. And then I've got a vertical one which is applied to that center line as well. I can't remember last time whether we talked about construction geometry. I'm pretty sure we did. But yeah, the center line of this sketch is construction geometry, which is why it's represented as a dashed line. And if we did cover this, then I'm telling you it again, but if we didn't, here's the new information. So the solid lines go forward when you OK this sketch to actually create the feature itself, whereas the dashed lines are essentially ignored by the feature. They're only there to either help us, the user, see something or do something, or to hold some other geometry that is a solid line in position. So this one's there to kind of control where this sketch is. So it governs where the actual sketch itself, and in this case, how long the sketch is as well. So it's, and where the center point is, which is critical for what we're doing. So yeah, construction geometry or just standard sketch geometry. So let's put some smart dimensions on it. Let's put the width. So we'll click on one edge and then click on the other edge to set the width. So that is going to be, ooh, that isn't how the drawing has dimensioned it. So if you look here, the way that these have been dimensioned is the length of them or the height as we're looking at it, because we're obviously drawing this at 90 degrees to that view. But the length of the slot is governed as the length of the center line, or referred to as the center length of the center line, and then the width of the slot has been defined as it's the radius of curvature of each end. So let's insert the dimensions as they're shown on there. So I'm just going to click on my dimension that I've just inserted. Let's try that again. In fact, let's just cancel there and then press the delete key like that. So to delete the dimension, you just select it without having the numerical entry box open. So you've got to shut down that numerical entry box first, and then select the dimension that you want to delete, and then just hit the delete key on the keyboard. So we want to dimension the radius on the end. So what I'm going to do, with the Smart Dimension tool still selected, just click on that arc, and then you should just be able to place that radius. And it is 1.8. So 1.8 on the end. And then the length I've already said is either the length of one of these edges or the length of the center line. Doesn't really matter which one you apply it to. I'm going to pick that edge. Is 3. So that's what we should be looking at. So I'm not going to add any more dimensions now. So I'll press escape. But what I do want to do, I want to lock it horizontally into the center of that sort of gap there. So again, I'm going to sort of insert a piece of construction geometry to allow me to hold it in position there. Which again, I'm pretty sure we did this the other week. You will forgive me because I'm teaching about 6 or 7 SolidWorks sessions every week, so they do blur into one slightly. Where can I find the recorded session? If I haven't uploaded that yet, no, I don't think I've uploaded yours yet. Yeah, I will drop it in here, basically. Sorry, you can't see that window. Sorry, I was pointing at it on my other monitor. So, yeah, I will just drop it in here, probably either just before this section here, weeks 1 to 4, or just after it there. But it'll be obvious. If you come into the learning materials, I'll label it as tutorial, whichever number it was. So yeah, I'll put them in there. I think what I'll do as well, I've been uploading them to the shoe site directly as video files. And somebody asked me to, if possible, just upload it to some online service. I think he mentioned a different one, but I think what I'll do is I'll just upload them to my YouTube channel. And what that means is you can fast forward through them easier, and you can slow them down and play them more slowly if you need to. Yeah, so I'll do that, and then I'll just put the link in there to it. So that's that answered. Yeah, someone's saying, yeah, it's much easier going through it. I agree. It's easier to skip through the video as well and just look for the screen that is sort of showing what you're stuck on, I think, than going through it in a sort of textbook style PDF. So yeah, I agree with you, and I'll upload them onto there so you can do all that. But there is a link. Hold on, just bring that back. So that's sort of to a little piece of my stuff that I've uploaded to YouTube. So there's relevant stuff in there. Certainly when we get later on, and we're doing things like solid cam, and we're doing simulations on I-beams and things like that, and design studies. I've already pre-recorded a lot of that, and there's obviously the SolidWorks drawings ones there that I've sort of pointed at already. But yeah, there's a link that's permanent in there to that, which is that one there. But yeah, I'll put the specific session links in there as well. So, right, anyway, back to what we were doing. So I'm going to use the line tool initially just to sketch a solid line. And I'm going to lock the solid line to the center point of this top edge. So again, I'm pretty sure we did something similar to this the other week. So if you see, when I hover over that top edge and go near the center point of it, the actual true center appears as a little sort of square box looking thing. And when I get near it, the system offers me a coincident relation to lock onto that. So I'm going to click, and then you can see the end of that line's now locked itself onto there. And then the other end, I'm going to lock it onto this arc. And again, when I get near the center point of the arc, the true center point of the arc appears. So you can see there's a little square box there appearing in dead center of that arc. And again, if I click on that now, my vertical line is locked to the exact center of that arc. So when I've got the two ends of that line placed, I don't need the line tool, so I'm going to hit escape. And then if we just drag our sketch about, you can see it is doing what I said it should do, which is the ends of that line have locked themselves onto the center point of both that edge and that arc. So all I have to do now to lock it into the position that I want is tell the system that this line should always remain vertical. So if I select the line itself and then add that vertical relation to it, so you can see the vertical relation icon there. So lock that, and then everything turns to fully defined. So you can see everything's turned from blue to black. The readout at the bottom now says fully defined. There's one last thing that I need to do, which is I said this line needed to be construction geometry, which at the moment it's solid. So if I was to OK this and try and create an extrude cut, the system would throw an error and say, you haven't created a single closed boundary. You've created a closed boundary and then an open boundary or a single edge, which it wouldn't be happy about. So if I want to complete this so that it can use it for an extrude or an extruded cut, I have to select that line and then click on that icon, which you can see from the icon. It turns it from a solid line into a dashed line, like that. So now it's construction geometry. So we're happy. And for one final check, when we were talking about creating closed boundaries of edges, it seems from this view that the system's not shading in that slot shape, but it's just because the part itself is obscuring our view of this sketch. If we rotate around a little bit, you can see the sketch is actually sandwiched on that sort of plane that passes through the middle of the part, and you can see that it is actually shaded in. So yeah, we're happy with that. We can click on OK to exit the sketch, the little blue icon at the top right, and then again it's rotated my view back around, so I'm just going to manually rotate it so I can sort of see what's happening a little bit clearer. I can see that it's been extruded out, this extruded cut. It's going to 10 mil, which I'm not particularly happy about, because even though it's passing through this surface at the moment, if the design was to change and this diameter was to get much bigger, then this cut might not go all the way through it. So what I'm going to do is change that from a blind value of 10 mil to probably through to next would be my preference, because I'm sure I've talked about this before. The through all is a bit of a crude way of getting what we require done. The through all will just keep going and going and going and cutting through whatever surfaces you design possibly out here in the future. It will continue to cut all the way through. Whereas the intention of this design is that this cut cuts through to that outer surface and no further. So up to next is probably better in this case. So that looks good. It's doing what I want it to do. Click on OK. We don't get any errors, so it looks good. Yeah, so we've created one. It's put it in the feature tree. So now what am I going to do? I just temporarily clicked off it there, so it was selected in the feature tree, and I just clicked in some free space just to deselect it, if you like. Now what I want to do is I want to create a pattern of these that rotate around the center axis of my part. So my part has a center axis that we can't currently actually see. And if you want to make these center axes visible at any point, it's in the drop-down menu up there where we hide the base planes, that drop-down menu. If you have a look in there, under the two base plane icons, or the primary planes and the all planes icon, there's two like dashed lines, and one is to view axes that you have specifically inserted into the part. So we haven't inserted any into the part specifically as its own feature. So when you click on that, nothing appears. But the other one is what's known as temporary axes, which if you click on it, a few of them should appear. So it's not immediately obvious, but there's one running straight through the center of our part there. It's just a little bit obscured by the fact that we can still see the base planes. So let me turn the planes off, but leave the temporary axes on. In fact, I'll keep flicking them on and off, and you can see the effect that that's having. They're highlighted in blue, and there's one running down the center of the part there. So that was created from our revolve that we did initially. So any revolved feature ends up with a temporary axis that runs down the center of it. And then there's some more up here where we've cut our slot through. Again, because we've got a cylindrical face there, it has this sort of virtual or temporary axis running down the center of it. And then we've got a final one there. Because we use the center point slot, there's one that runs straight down the center of the slot as well. So there. So yeah, temporary axes. You don't really have to leave them switched on because the pattern that we're about to create knows that they're there, and therefore you don't have to directly click on them. You can click on a face that is part of that revolved feature, and the pattern will take your input to mean that you want to use this temporary axis. So you don't really need them switched on most of the time, but it's worth knowing that they're there in case you have to reference them with some sort of sketch or feature that you want to create. So we're going to switch them off. We're going to switch the visibility of them off, that is. So we'll go back in there, turn temporary axes off. So we deselect that icon there, turn the planes back on, and then we're ready to do our pattern. So we're going to pattern around the center axis. And again, there's a type of pattern up here as a feature, but that's not quite the one that we want. We want one of the other patterns that's available in that drop down arrow. So if you click on that, circular pattern is the one that we want. So I'm going to click on circular pattern. And then this basically needs 2 inputs and then a numerical value. So the first thing that it requires is it kind of draws your attention to any boxes that require some user input. And it draws your attention to them by highlighting them in blue. So if you hover over that one that's highlighted in blue, it's basically saying what features do you want to pattern. So I want to click on some face that was part of that slot that we cut through. So it could be that face, could be that face, could be that face, or it could be that face. They're all included in that cut extrude feature that we created. So we'll click on one of those. So it's accepted that. It said that's part of the cut extrude that you just created. There it is. Then what we need to give it is a direction. So up here where it says direction 1, if you click on that entry box, and then it highlights it in blue. And given that it's a circular pattern, you only have to pick a cylindrical surface as a reference. So anything that forms a cylinder. So in our case, anything that was part of that original revolve. So all these cylindrical surfaces are fine for that. So I'm just going to pick that big one there. And essentially what it's done is it's looked at that cylinder and it said, that cylinder has this temporary axis that runs down the center. That's what I'm going to reference as an axis to spin your feature around. And you can see I'm getting a preview that's showing 5 copies of my feature spun around that center axis. So we don't want 5 copies. We want 4 in total, including the original. So that's 3 copies plus the original. So that's 4 in total, which I'll just go back to the reference. So there you go. That's just sort of proving it. So there's one there, one there, one there, and one there. So the system counts the original as one of the number of instances. So if I hover over this box here that says 6 in it currently, and just turn that down to 4, so that looks about right for our purposes. And then if we just want to play around with some of these options, seeing as we're in here, I mean, that's actually finished now. That's as we want it, but just for reference. So you can see I've got something called equal spacing selected there, which basically means it's going to take this number of degrees and it's going to chop it up into equal amounts of these amounts, basically. So it's going to chop 360 into 4 equal amounts. So it knows that each pattern member is going to be situated 90 degrees away from the last pattern member. So that's what equal spacing does. And if I was to play around with the number of degrees that it goes through in total, you can kind of see the effect that it's having there. So you can see if I start reducing the number of degrees, it will respace all the pattern members to fit what I've asked it to do. The other option is you have this tick button selected, so you can then specify the actual spacing in degrees between each pattern member. So you can see when I spec it as 15, they're all on top of each other. I'm not moving them enough away from the original so to not have them overlap each other. So that's what would happen at 15 degrees. And as I increase that value, you can see the spacing of them's going up and up and up. So yeah, if say I wanted 58 degrees between each one, I could do that as well. So there's two ways of speccing these circular patterns, either total number of degrees that the pattern goes through with all pattern instances, or the gap in degrees between each pattern member. Yeah, I think we'll leave that there. We're going to come back in a later sort of tutorial and have a sort of greater look at the different types of patterns that you can create. But yeah, that's good for us. So it's 360 equally spaced, 4 pattern members, and then we can click on OK. And that should be the completed part, unless I've missed anything off it. I don't think I have. Yeah, I think we're good to complete that. There are some things, just looking at our reference there, that I don't really want to get into at this point, but we will touch on later. So I'm just zooming in on this area of our drawing that we're working from. And a few things that you can see from there, apart from the fact that this drawing has had its sheet border customized to the specific requirements of this company that was drawing these. Some other things to note there is you can just about make out it says material there, and it's 304 stainless steel. And then it's got treatment, which I assume is surface treatment, and it just says natural, as in untreated, just purely machined metal. So these sorts of values or these sorts of properties can be entered into your part model. So you could keep a record of what material it's made out of, what its surface treatment is, even who it was created by. So these are the initials of the person that both drew this drawing and created the model as well. So all of these things, and this last revised date as well, all of these sorts of things, you can actually store them within the SolidWorks part itself, which I think at this point is just good enough to make you aware that that's possible. Later on, we're going to touch on how you do that, but I don't think we'll cover it at this sort of early on in the course. But yeah, just be aware that that's possible. And when you do store them in the part, which is by far the wisest way to set them up, it means that when you come to the drawing, the relevant boxes there in the drawing title block just get automatically populated. You don't have to actually type them in. You just bring the part in and say, I'd like to create a drawing of this part, and the system goes, right, I know it's made out of this material, I know it's got this finish, I know this person drew it, and it will just automatically put the values in those boxes. So it's by far the smartest way of controlling all that extra data. I suppose in today's day and age, you'd call it metadata, which you have attached to photographs or various other types of file, audio files, MP3s. Yeah, they all have metadata attached to them, which is like extra data over and above the obvious stuff. But anyway, so we've finished modeling this part. We're going to take a save of it at this part, and then I will upload that save right now so that anyone that hasn't got it from last week and has just been watching can then download my version of it, hopefully, and it should work. So yeah, I'm going to take a save of this. I'm going to navigate to where I want to save it to. It's just saved it where it was before. So I've just got to try and figure out where it is. So I literally just clicked on save. If you'd never saved it before, it would then ask you, where do you want to save it? What name do you want to save it under? But I'm going to see if I can find the thing. So is that it? I believe it probably is. Yeah, Revolve 1, and it's in that. So if I now do an upload of that, I'm just uploading on the other screen, so just bear with me a second and I will tell you when I've uploaded it. So performance engines, yes, that's us. So I'm going to drop it in that subsection that says weeks 1 to 4. So I'm going to drop it in as a separate file in there, and I will give you a shout as soon as it's in there. So I'm just finding it. There it is. And it's just uploading, hopefully. Right. So if you do a refresh on there, so I'll prove to you that it's actually there. So here it is, and it's that one at the bottom. It's called Revolve 01 SLD PRT. So the SLD PRT extension just means SolidWorks part. So solid part. So if you want to download that onto your machine, which should be as easy as, how do you download these things? If you right click on it, save link as, possibly if you're using Microsoft Edge. But yeah, I'll give you a set just to do that if you need to. And then wherever you save it to, if it drops straight into your downloads folder, you'll have to go into SolidWorks and go open new file, which is, I don't think we've used open file before. So it's that little folder that's got like a green arrow coming out of it to open a new file. And then you navigate to where you want to load the file from, the folder, and just double click on it, and it should load it in. So yeah, just while you're doing that, so I'm gonna shut my part down, because when I create this drawing, I want to show you the method that you create a drawing if you were coming into SolidWorks afresh and you didn't have any files open currently, because that's kind of the most foolproof way of showing you how to do this. So I'm just going to shut mine down. Not the whole of SolidWorks, obviously, just the part that I've got open. So that's something that we're going to do later there, which I don't need to save at the moment. So yeah, imagine you just come into SolidWorks. Either you had modeled this part previously, or one of your colleagues had passed you it and said, can you produce a drawing of that? So what would you do? You'd go new file, just like we've done before when we're creating new parts. So you'd go click on that sheet of paper at the top. It brings you into this menu. We've already said we're going to be creating a drawing this time, not a part, because we've already created a part. So we'll double click on drawing. And then the first thing that we're confronted with is, what sort of sheet format or sheet border do you want to use? And what you might be looking at is a much smaller list than I've got here. So you can see I'm scrolling down through my list. I've got lots of different options. If you've got that box ticked there, only show standard formats, you'll have a very short list. And what that's showing you, if the first time that you booted SolidWorks up and it asked you what sort of international format do you want to set your default to, and I clicked on BSI, so it's only showing me the BSI formats. So that's why that list's really short. But for this example, I'm going to use an ANSI drawing sheet format. So I want to untick that, and then I get the full list that SolidWorks comes with when you install it. And the one I want to use is an A4 landscape one, and it's that one. So A4, it's part of the ANSI standard, which tends to be a sort of more American standard than BSI or ISO or DIN. But yeah, that's the one that we're going to use for this example. Just because it's one of the few in there that uses a simple A4 sheet in landscape orientation. Because a lot of these are set up for people who have large format printers or possibly plotters that will plot up to A0, they're not really suitable for a little desktop printer that's only A4. So you struggle to find one that's the correct landscape orientation and in A4 size. So we'll pick that one. ANSI landscape is what we want. Then we click on OK, and then it generates a sheet for us. So you can see there's a drawing sheet already there. It's got a default drawing to it, and what it's waiting for over here on the left hand side is for us to point at a part document to say this is what we want to create a drawing of, this part here. So there's nothing open currently. If we had left that part open, it would be listed there, and it would make our job easier. But I'm showing you the sort of most foolproof way of creating these things. If you've got no parts open, you've got to browse your system and find the part. So I clicked on browse. I'm already in the right folder on my system, so there's the part that I want to use. So I'll just click on it, click on open, and then two things have happened. This menu's changed, so it's accepted my input, and we're now at the next stage of this drawing creation. It's given me a box that represents a view of my part that I can place on this sheet. But that's not very user-friendly because I can't easily see what this view looks like. I can just see the size of it, which is not terribly useful. So if I click on preview over here, which you can see is not currently selected, then what I get is I get a preview of what my part looks like from this particular orientation. And then what I'm going to do, I'm going to quickly look at my reference again. So what are we trying to aim for here? So let's resize this a little bit. There we go. So there's some decisions to make here. I would say that this I would regard as the sort of primary view. And then this view has been projected away from it. And then this view has been projected away from it. And arguably this 3D one as well. And then this one's obviously a cross section over here. So I would sort of regard that one as the primary view. So what I'm aiming for is to place that one first. It's not essential. I could place this one or this one first, but that seems to make more sense to me. So what I'm looking for is that view. And the way that I select different viewpoints or different perspectives of this part is down here. So you can see I've got front currently selected. And if I just experiment a bit, say I click on right, then I'm looking at the right view there. Click on left, it just looks like the right view, but it's mirrored, obviously. I can look at it from above, so we've got top view there. So yeah, you get the idea. I'm fairly sure that is the one that I require. So the one that it was on initially, the front, is the one that I've deemed the sort of master viewpoint, the primary viewpoint. So I'm going to just click there to drop it. So that's now been dropped on the sheet. And what the system does next is wherever I move my mouse pointer, it projects a view away from that initial one. So you can see I'm getting a projection down here, I'm getting a projection over there, and then if I go up above, I get one, and over there. And then even if I go sort of diagonal, I get sort of a 3D projection away from that original view. So yeah, that's the behavior. So what I'm going to do, I'm going to place one there, and I'm going to go back up to this one, and I'm going to move over to this side, and I'm going to place another one there. And then I'm reasonably happy now. So I don't want to place any more views currently. I want to do something else now. So I'm going to click on the green tick over here because I don't want that behavior. I don't want to place any more right now. So click on the green tick, gets me out of that menu. So there's a few things to sort of have a look at here. The method of projection used on this drawing seems to be a little bit different to the one that we've got. I'm just trying to get my head around. So if that's the front view, so yeah, this one's third angle projection, which it says at the bottom there, and I suspect our systems have defaulted to first angle, which again, I'm not going to get into the ins and outs of the difference between third angle and first angle. Yeah, that's sort of a Google search away just to define those terms. But I will show you how to switch between the two in SolidWorks, or when you're creating a drawing in SolidWorks. So that's part of the sheet setup, whether you're using first angle projection or whether you're using third angle projection. So if you look on the right there, there's an icon that says sheet on it. So sheet 1, this drawing sheet is sheet 1. So if you right click on sheet 1 over there, go down to properties, and there's your option. So first angle and third angle. And we are actually using third angle at the moment, so that's interesting. But anyway, the advice stands true. That's how you change it. And in general rules, if you're producing American destined drawings, so that go into American firms, let's say, you will probably use first angle, whereas over here we tend to use third angle projection. So you can change it in there. But we'll plow on. So what are we going to do next? We'll persevere, even though our view of this one's slightly different. Just let me try something. Are we viewing our part from the right direction there? That may be what's causing this to go a little bit awry. No, that's very odd. I don't quite understand the original drawing that we're using there. I think whoever's made it has sort of made a little error on one of the projections. So anyway, we'll assume we're right. And I may give that a bit further investigation later on. So we've got 2 projected views. What else have we got on this drawing sheet? We've got a nice 3D view that's shaded down here. So that it might be useful to know how to insert these. So traditionally, if you were producing these sorts of drawings by hand, you probably wouldn't include a view that looks like this, just because the amount of work involved to manually create something like that is not really worth the return that you would get. So the return would just be giving the viewer of this drawing a really quick, instant way just to get a sense of what the form of this part looks like, and nothing more than that. You don't really get a huge amount of technical information off that. It's purely just as a glance past it, and you get a really quick sort of sense of, oh, right, that's what it looks like when it's produced. But with 3D CAD, it's dead easy to drop one of these views in. Normally, when I'm producing one of these drawings in SolidWorks, if I've got the space, and only if I've got the space, I might drop one of these down near one of the corners. So, yeah. But yeah, it's dependent on how much spare space you've got on the sheet. So let's drop one of those in. So the way that you would do that is in the new toolbar that's appeared at the top. So you can see all the toolbars for creating drawings are kind of unique to drawing creation. I mean, we've got a common one there in the sketch toolbar, which is kind of the same as when we're working on a part. But other than that, these first 2, we don't really get those when we're creating parts. They're specific to drawings and drawing setup. And really, most of what we're going to do in drawings is centered around those 2 tabs. So we're either sort of adding something extra to the drawing, like a new view, like we're about to do, projecting a view away from something, auxiliary views, section views, detail views are another common one. Broken out sections are quite useful. If you've got a really long component that doesn't change much along its length, you can put a break view in there so that you abbreviate a really long, thin component. Yeah, all the sorts of adding views, and then annotations cover everything else, basically. Dimensions, balloons, little notes, surface finish symbols, weld symbols, hole types, hole callouts, everything else is covered in annotations. And a lot of these others will not really use them as much. So we're primarily working in these first 2 tabs. So let's put our new model view in. So click on model view to place a single view of the model. There's only one model currently open in the background or in this sheet, and it's the correct one, so it's Revolve 1. If you had multiple files open in the background, they would all be listed there. So, yep. So we'll go next, little next arrow at the top there. Next screen, please. Then it's offering us a view. You can see it's actually offering us the same view that it offered us when we came in. We don't want that one. We want an isometric view of the part. So you can see down here, we've got the standard sort of normal 2 views, and then we've got a more sort of 3D one like that. So then I can place this wherever I want. I'd probably make the call to put it a little bit further down near the bottom of the sheet here to try and separate it visually from these ones. And then the one in the reference is shaded. So you can see it's sort of a shaded line drawing. So we can set that as well. So any of these views, so I'll just temporarily click on some of these other views. And when I click on them, I tend to, just through habit of using SolidWorks drawings, is click on the box that appears around it. It's just a safer way of selecting a view than trying to click on the actual object itself. So you've got to realize that these views are sort of self-contained within their own little viewport, if you like. And as you approach the view on the drawing page, that viewport sort of highlights. And it's easier to sort of select the view that you want by clicking on the viewport or the edge of the viewport. So I'm going to click on the view that I want to change. It's this 3D one, so select it like that. And then everything governing how that view appears should be available on this sort of view dialog that pops up on the left-hand side. And the thing that I'm interested in is this section, display style. So it's currently set to that one, which is, it's a line view, but it removes all the lines from the other side of the part. So it doesn't look like that, a huge mess of edges. It looks like that. So the edges on the back of the part have been hidden from my camera. But the one that I want is that one, shaded with edges. So you can have a play with those. You can see the different types that you can activate. And if we haven't covered this already, when you're in part mode, these same icons are available. So as you're viewing a part and you're modeling the part, you can switch it to wireframe display if you need to see something on the other side of the part, or you need to be able to view through the part itself. So yeah, shaded with edges is probably the clearest one. So that's the one that I'm going to pick. So what else are we going to put in here? Let's put this section view in. So again, if you don't know what a section view is, essentially we've taken a knife, we've chopped down through the middle of our part. As I use different planes to you, this view is the wrong way around for me. Yeah, so you might have to, if you sketched your initial sketch on a slightly different plane, then this view that you drop originally won't be referred to as front, but you'll just have to search through the other options to find the one that looks the same as this, and then you should be okay. So yeah, make your view look as mine does, but don't too slavishly stick to the exact setup that I've got, because you may have produced yours spun through 90 degrees from mine, so it may be slightly differently orientated in the part modeling environment. So yeah, you're aiming for something that looks more or less like this, though, which you should be able to get to. So let's put the section view in next. So yeah, section views. So this is a section view. There's the view, section B. There's where it's come from, or where it's sectioned from. You can see that's a section line that runs down through the center of that view. It's been labeled automatically by the system as B. So it puts the letter B at either side, which is why it then puts the label B/B, because it's cutting from here all the way through the parts up to there. And then the part's being viewed once it's been chopped in half from the direction of the arrows, or from the perspective of the arrows. So we're looking into the part from this side. So this side remains. It's been chopped down that line. This side's essentially being removed and thrown away, and we're peering into the part from this direction, from the perspective of this arrow. So that's what we've got there. So let's insert that view now. So again, we're going to insert a different type of view. So we want to be in this drawings tab where we already selected that model view option to put this view in. Hopefully you can see that most of the icons are sort of self-explanatory. If you know the type of view you're looking for, combination of the icon and the actual text, you should be able to figure out which one of these is the right one. And you get those nice tooltip pop-ups that sort of appear as you hover over each one. So you get even more information. So it's like the system's got its own sort of help file permanently active to sort of help you find the icon that's going to be the view that you need. So yeah, section view. We'll click on it. So there's a few different types of section view here. For these sort of simple drawings that we're going to do, I would say these top two are going to suffice. So essentially you're going to section a part vertically, so you're going to chop it down from top to bottom, or you're going to section a part horizontally. There are angled sections and sort of fancy looking aligned ones as well. But yeah, certainly for these simple drawings, horizontal and vertical are going to suffice for us. So vertical is what I want. And then when I have vertical selected and sort of move around my drawing sheet, you can see there's a pink vertical line which is sort of offered to me to drop on any one of these views. I'm not sure. Oh, you can put it on the 3D one. I've never tried that before. But anyway, it's this view that we've said that we want to section. And more than that, we want to section it at a specific point. We want to section it right down the center. So again, because in a sense, where we are placing this section line is defined by a sketch, essentially. We can't quite see that it's defined by a sketch. We've got this fancy interface down here and this pink line that's following us around. But essentially all we're doing is placing a vertical sketch line. That's all we're doing. So in the same way that when I'm in a sketch, I get the relations offered to me as little yellow icons when I get near things. So you can see when I get near the center point here, it offers me a coincident relation. And when it does do that, I want to click. So that will lock the section line onto the center point of that edge that's highlighting in orange. So you can see there's a circular edge there highlighting in orange from our part, and the center of that circle is where we're going to lock our section line onto. So we'll click there. Then we get some sub options, which are to do with, you can have these offsets in your section line where you get a really fancy section. I'm just quickly trying to find one on the other screen. I was looking at one earlier that I was considering for us. Here we go. Here we go. So here's a good example of what I'm talking about. So you can see on this part that is actually on the learning materials for you to have a practice on at some point. We might have a go at it in class. You can see AA section line cuts through the part here, but then when it gets to this center point here, it turns a corner and cuts down there and ends there. So when you have a look at the section here, you're not looking at just a simple flat cut through the part. You're looking simultaneously in two directions. So it's a little bit hard initially to get your head around that. But essentially you're looking outwards through this section line there that I'm indicating with my pointer. And then when you get to the center point of this circle, you then switch and you're looking outwards through this section line. Now that's a more sort of advanced way of sectioning things, but it is available. You can set that up in your SolidWorks drawing. This drawing was created on SolidWorks. This is from I think it's a convention in Las Vegas called SolidWorks World, and they have these little challenges where they challenge people to model these things up as quick as possible. So yeah, there's quite a lot of those. That one there and that one there. I think there's some more later on for you to just have a look at, if nothing else. So we'll get rid of that. That's my other lecture just being encoding. Get back in SolidWorks. Right. So at this point, we're not going to put any of these fancy options in. So we just want to click on the tick. You're going to almost disregard this bit of the menu for the time being. But just be aware that it is there. If you need to produce one of these angled section lines. There's all these other options, but we're just going to tick straight through this because we don't require any of that. Then what we've got our cut through view or our section view. And the only place that we can place it at the moment is in line with its parent view. So its parent view is the one that we've just locked the section line to. So it was that first view that we placed. And this view is a projection away from that, essentially. So you can only go away from it at 90 degrees to the section line that you've created. So yeah, that's why we can't drag up or down with this view. So now I'm just going to place it. So click and place that like that. And then a few things to note. So what has it done there? It's picked the first available letter that we haven't previously used for a view, and it's applied it to this view. So in our case, we haven't created a detailed view or a broken out view or another section view. So A is the first letter that it comes to. So it's applied that. We needn't accept that if we don't want. If we want to give it a specific name, we can. So let's say we want to start at the other end. We can call it Z. And you can see all of these sort of associated with each other. You don't have to manually change that name and manually change the letter. They all get updated together, and you just either click on the line to select that section view, or you can click on the view itself, and all the options related to it, again, are listed down on the left-hand side there. So is there anything else that we need to specify about that view? Probably that although it doesn't look bad, so the section crosshatch, which is shown there, so you can see on a section view, you get this crosshatching effect going on. And you can go in and just click on that in the view. So if I just click on one of those lines, click on them, you can then go in and edit that. But what it's currently set on is whatever the material I specified for this part has its own sort of crosshatch type or pattern, if you want to call it that. And by default, the default type is set to this simplest of crosshatches, just diagonal lines at 45 degrees at a preset spacing, and that's it. But if I wanted to go in, I could deselect that, and I've got a great big list of things that I can pick from. So you've got stuff like masonries and clays and all that sort of thing. So again, we're not going to change any of that at this point. Just be aware that it's there. Because if you're creating a section view of an assembly, it's often useful to create different crosshatches on different components within the assembly. And other than that, I think we're happy with that view. It's reasonably similar to what we're working from. What it might be nice to do is just place a center line down that view, because it has got some cylindrical faces included on that component. So normally what you would do is you would put a center mark in on the end view. So I would class this as we're looking down the cylinders from one end, and so the system automatically put us a center mark in. So I'm clicking on it now. So that blue X, which runs through the center of all those circles, is known as a center mark. And you can see that when I click on it there, the properties for that center mark are displayed. And then the sort of matching feature, but when you're viewing a cylindrical face from the side, which is what we're doing here, so that is a cylinder, is to put a center line through. And you can do that. So that would be classed as an annotation. We're not placing a whole new view. We just want to add some annotation of some description to an existing view. So we click on the annotations tab, see if we can find the word centerline. If you search for long enough, you can see it there. You can see the little icon is kind of explaining what it does. And then the tooltip that pops up kind of does that again as well. So centerline. The only thing that you have to click on, so you can read through all this, but essentially click on a face that you know is cylindrical or even conical. So that face there is a cone, and that face there is part of a cylinder. So I'm just going to click on that, and the center line gets dropped in. So really easy. You can even, well, we'll not do it that way. Yeah, we'll leave it as simple as that. Click on a cylindrical edge or click on a conical edge or face, and it will drop a center line in for you. We could put one on this view as well. Let's do that now. So we'll click on that face. Yeah, so we got one in there. We could even put one on that view if we wanted. So let's go back. Let me just read some of these chat things that I've just missed. Different planes. Is there a way of flipping? Bottom left one. I've used different planes to you, and this view is wrong. So I think what someone's touching on there, I was sort of talking about. Oh, you've sorted it out. What I was about to do was say you can rotate individual views. So let me do it on this one. So there's a rotate option at the top there, and you can rotate an individual view round at set number of degrees. So yeah, that is an option, but hopefully you won't have to do that. So what are we going to do next? Let's try and get as close as we can to the one that we're working from. So there's a lot of dimensions on there. Let's have a look at putting these tolerance dimensions in, or rather pulling them through from the part, because I said we're going to store those in the part itself, which one of the things that allows you to do is to not have to reinstate them in the drawing. You literally just pull them through from the part and they get inserted into the drawing. So let's have a go at doing that. So the view that we're going to put them on is the sectioned view. So let's keep that in mind. So we'll pre-select that view. So we'll click on it. And then it's an annotation again, but in this case, it's a model item. So it's in the part model itself. And if you hover over that, again, the description sort of says imports dimensions or annotations or reference geometry from the reference model. So what it's talking about is the 3D model that we created that is the part file. So if we click on that, and then this first box has already had our section view placed in it. So if we hadn't pre-selected that view, that box would be empty, and then we would have to click on it. But as it is, it's put section JJ in that box. Then what we want to do is we want to say, I don't want to click on a specific feature to import these dimensions from, these tolerance dimensions. I just want to import them from the entire model. So we want to set the source to entire model. But then what I want to do, I don't want to import every single dimension, so that's a bit messy. What I want to import is just the ones that I've specifically put tolerances on. And hopefully you can sort of tell that one where it says X and then it says point XX and point X, that's the one that sort of tells the system that you just want to import the dimensions that you, the user, have put tolerances on. So we only put tolerances on 3 dimensions in this part. So if we click on that to activate it, and then we should, I think if we've got this right, be able to click the green tick. And it's brought them all in. I thought it might do that. So I made the mistake there. I didn't deselect import all other dimensions as well. So at this point, you could start trying to arrange these, but I don't recommend you do. What I recommend you do is click on undo. So it's that little blue arrow at the top, and then we'll try that again. So model items, I want to import them from the entire model. I don't want to import them into every single view. I just want to import them into this view. So I'm going to untick that box that says import items into all views. No, I don't want to. Then it's highlighting this box, so it's saying what view do you want to import them to. That view there, section view. And we do need that tolerance dimensions option selected, but we want to deselect this first one. So you can see that first one is also selected, and that was my mistake, having that one selected as well. So just click on that once, and that should be it deselected then. And then we'll try that again. So click on the green tick. Yes, success. So we just got the 3 that we, as the user, specifically put some tolerances on. So that's how you import them from the model. Now I'm having a bit of trouble selecting that one. And then all you have to do is kind of lay them out in the manner that is most clear on your drawing. So I'm just manually just clicking and dragging these around, trying to get them as sort of legible as I can on this drawing. So something like that, I think, is good enough.
How do you get the dimensions to be sideways like that? Because mine are like horizontal.
Ah, that's interesting. Okay, so occasionally we run up against stuff like this where I've made a customization to my software many moons ago, and I've forgotten that I'd actually done that. And you're looking at the default installation. So let's have a play around with these and see if I can put mine back to what you're seeing on yours. So one of the ways that you might do that, so if you select one of the dimensions, so get it highlighted like that, and then so what happens is all the options for that thing that you've selected always appear on the left hand side here. So you can see broadly options to do with dimensions are split down into 3 tabs, and then if you click on the one that says other, you might be able to, ooh, is that the right one? No, it's probably not. It's going to take me a second just to play around here. It's a very good question. Okay, leaders. Let's have a look in the leaders tab, and let's go custom text position and try selecting each one of those 3 at the bottom. So is that more like what you're looking at?
Yeah, that's why.
Yeah. So yours is defaulted to that version, I think, whereas I've got mine set as default to one of these other versions. So there's that. So it's just playing with the position of the actual text itself. That's all. So yeah, mine I have set as default to that, which will kind of cover setting the defaults for drawings. But I think probably to get through this particular example, it's easy enough just to, if you do a bulk select on all of them. So if you click on a dimension, hold down Control, click on another one, keep Control held, and then click on the third one, you should be able to go in there and play around with all 3 of them simultaneously. So yeah. But that behavior, whether they're aligned or not aligned with the line, you can save that out as a template, and you can tell the system, can you use my custom template every time I produce a drawing, please? And it will do. Whereas I think what you're seeing is that's the default. Just a fresh installation of SolidWorks will just default to them always being horizontal, which isn't the best. Especially, I think the main reason I changed mine is I produce a lot of little A4 drawings, and space is always a premium on A4 sheets. So if you have horizontal dimensions, especially if you've got tolerances after them like this, you end up wasting lots and lots of space. So it's always better for me if I align them with the actual dimension line. So I'm tempted to, shall we save that now? Yeah, I never like to do too much on drawings in one chunk, because it is kind of a, yeah, you can lose people after a while. And I think it's better if we sort of keep doubling back and keep adding a bit more detail and adding a bit more detail and so on and so forth. So I think we'll probably save that one at this point. So saving it, the exact same procedure as saving a part file. If you go to that icon at the top, which is the save icon, hopefully we've sort of established that by now. Click on save. It gives you a little warning probably. Do you want to update the drawing views? Yes, you do. That's not going to really damage anything. So yeah, update everything before I save. Then it should navigate into the folder that you saved the part file in. So that's what mine's doing. I can't see the part file in there because it's got a filter activated here that only allows me to view drawings files in there. Someone's sketching on my screen again. I wish I knew how to switch that off. Yeah, clear all drawings. Yeah. So, what it does by default is it gives the drawing the same name as the part file that it is a drawing of. And I suggest you keep that as the default setting. It gets really confusing if you start giving the drawings a separate name to the actual part that it is a drawing of. It's far simpler if you just leave it as what the system defaults to, which in my case is revolve01. But it won't overwrite the part because they've both got a different different file extension. So you can see drawings have got a .sld_drw for solid drawing, and SolidWorks parts have got SLD_PRT for solid part. So yeah, so I'd just suggest you just click on OK and don't bother renaming it. And try, if possible, always keep the two in the same folder. Don't try and section all your drawings off into their own folder and then section all the parts off into another folder, because it inevitably ends in disaster. And the drawings, in order to load, need to know where the original part file is. So if you shut SolidWorks down and then section all your parts off into their own unique folder and then pull all the drawings off into a different folder, the next time you try and load the drawing in SolidWorks, it will throw an error and it will say, I can't find the original part. So yeah, keep them all in a single folder and just go with the default drawing names. It keeps everything much simpler. So click on save there and it will save it. And I think what we'll do, certainly maybe a little bit next week, but possibly a bit further on down the line, we'll come back in here, we'll learn some more skills to do with this particular drawing, like customizing the sheet format and customizing how the dimensions are shown. And I don't know whether you can see on this, so if I get this example on the screen, the text on here is a lot smaller as well, which is, again, it's just a side effect of the fact that this is an A4 sheet as well. So the text's all being shrunk down. The arrowheads are slightly different. You can see the sort of legibility of these ones is a bit poorer. They're just simple lines. These are actually blocked in. What else can we spot on this one? Yeah, I think the font is slightly different on here. It's arguably a bit more legible. So yeah, there's lots of little tweaks that we can do. And when we've done them all, we don't have to do them on every drawing. We can just save them as the default then. And every time you create a drawing, you can either have them true default or you can have them saved and you can just point at them and say, I'd like to create a drawing using that standard, please. And you can make your own drawing standard. So yeah, but I don't want to over sort of load you with all that in one session. I think that's more profitable to keep coming back and adding a few layers onto that. Oh, there's layers as well. That's just reminded me. You can add various layers to drawings and hide them and show them and things like that. But anyway, let's shut that one down for the time being. Make sure you've taken a save of that, and then you can close that drawing down. So click on close at the top right there. So you should have nothing open at the moment. And then let's, so I was going to do a little bit of modeling and drawing work on that one, but I think we might drop back into the PDF and do a couple of exercises from that instead. So let's have a look, see if I can find the PDF here. So there's the PDF, Performance Engines and Tech, week 1 to 4. And if we scroll down a little bit, so we've done a lot of this already. There's some practice revolves there that are deceptively difficult to set up as sketches. if you want to have a go at them. That's what we've just done. There's another practice revolve. Hole wizards, fillets and chamfers. We should whiz through that one really quick. Just a quick question, just yes, no to the group. Did we cover the hole wizard feature? Just a yes, no from a few people, just so that I can remember. Anybody? No, don't think so. Okay, so this little bit will be worth doing. Although we've done chamfers at least, and I'm pretty sure we've done fillets as well. At least for the hole wizard feature, it's probably worth doing this little exercise here. So, yeah, let's run through this. I don't think it'll take us too long at all. So basically what we're doing, we're going to create a flat plate using the extrude tool. I don't think I've put any dimensions on here, but you can follow along with me. I'll come up with some dimensions on the fly. And then we're going to have a little play with the hole wizard feature and talk about what it does, why it saves you time, and yeah, some of the advantages of it. So let me create a new file, new part file, and then extrude boss base. I'm going to sketch on the top plane, and then I'm going to use the center rectangle tool, and I'm going to lock the center point onto the origin, and then drop that corner point, click on Smart Dimension, and here's where I'm going to dimension it. So I'm going to give it 150mm width, and let's have a look. Let's call it 100mm high, like that. And then I'm going to click on OK, and I've got to give it a depth now. So 10mm looks about right to me. Yeah, so 10mm will be fine for us. So I'll click on OK. So that's a fairly simple little box, basically. So what are we going to do next? I'm reading my own words here. Hole wizard, choose hole standard, hole type. Right, let's put some holes through this plate. So essentially what we're aiming for is that. Real simple plate. And it has some, you can't tell from here, but these are through holes. So they go all the way through to the other side of the plate. And these specific holes are what's known as counterbore. So there's a slightly larger diameter hole that stops there at that shelf, and then a slightly smaller diameter hole passes all the way through. So these are counterbore holes. And the fact that I've kept my sketch central about the origin point means that I can use a tool as I'm creating these holes to create copies of the hole that are a mirror image. So you can see hopefully there that the right plane is there, pictured, passing through the center of the part. I think this is the front plane passing through the center of the part in the other direction. And this position of this hole has been created, and then a mirror image of it has been created over there. And then a mirror image of each of those has been created. And the mirrors, if you want to think about them like that, are these base planes. So that's how it's been set up. So it's had a symmetrical relation inserted into it. So that's what we're going to do. But we're going to do all that within the hole feature, which is there. So there's an icon in the feature menu called Hole Wizard. And what this does, if you click on it, it'll open up on the left-hand side there. It essentially is a library of, in inverted commas, standard hole types that is stored within SolidWorks. So mine's defaulted into BSI again because I set my system up to primarily use the BSI standard. But if you have a little browse in there should be loads of standards. I'm not sure whether all the systems that we're all using have got all of these in, but they should at least have some of these in. So yeah, as it happens, for this example, I am going to stick with BSI just because I want a metric hole BSI contains metric sizes, so I'm happy with that for the time being. But other than that, if we work down this set of options from the top to the bottom, so the first thing that you kind of come across here is the type of hole that you want. And we've already kind of said this. We're going to create a counterbore hole eventually, which is that first option, which the icon sort of tells you that, but if you hover over it as well, you get the tooltip popping up as well to tell you that. But if we click through on some of the other options, there's a countersink, which is pretty obvious. So mine's just saying, you previously came in here and edited some custom values. Do you want to keep those? I don't. I don't want to keep any of that customization that I put in. So yeah, a countersunk hole like that, you would use a countersink bolt or a countersink screw to sit in that hole, and the head would be either flush with the surface of the block, or it would drop slightly below the surface of the block. So we've got counterbore and countersink. On a counterbore hole, again, it allows the head of some sort of fixing hardware to drop into the block slightly, so it doesn't foul on something else that may have to touch the top of the block. On the far right hand side there, we've got just a plain hole, which is essentially just a drilled hole that either goes all the way through something or stops part of the way down through it. So it's a blind depth, or it passes all the way through. Then on the next line, we move on to holes that have got threads in them. So there's a straight threaded hole, which is a straight tap. So that will be when you're manufacturing that, if you were putting it in metal, you would likely drill through or drill down with a set drill size, and then you'd swap the tool for a tap, and you'd go into the hole with a tap and put some threads in the hole. So you can see the icon there is showing you kind of an engineering drawing style representation of a thread form. So that little dashed line there that I'm pointing at is how you would represent a thread form in an engineering drawing. And then the next one on is a threaded hole again, but this is a special type. This is a tapered thread, which you tend to get in. So historically in this country, I think they've been referred to as gas threads, because they've been used on the gas system to, as you wind two threaded fittings together, it tightens as you wind it, the fitting further into the hole. So it sort of creates a seal, or it promotes the creation of a seal if you put some thread sealant on it as well. So yeah, they tend to be airtight threads, the tapered threads. And there's various standards. There are more sort of British and European standards, and then American standards in there as well. The third type we can almost disregard. This is for previous users of SolidWorks. So older versions of SolidWorks had different hole types, and they've been included and packaged together in that legacy hole. That's sort of legacy versions of SolidWorks. So we can almost disregard that. But you do get a lot of customization options in there, but it's easy to ruin the standard that you're trying to maintain by manually editing all the values. And then the bottom three are just copies of the top three. So we've got counterbore, countersink, and straight through, or straight hole, but in slot form. So you've got counterbore slot, countersink slot, and then just straight through slot. So you might put those into a component whereby, what am I thinking about? I'm thinking about possibly when you put disc brakes on a bike, on a cycle, you can move the disc brake caliper around, because the holes that attach it to the threaded mount on the fork or on the frame are slotted. So normally you would have a fixing that passes through a slot, and when you tighten the fixing down, it clamps the component in that position. But because it's a slot, you can slacken the fixing off and move it slightly, and then retighten it again. So yeah, slots are useful for that. So you've got your basic hole types. So let's select the one that we intend to use. So counterbore. Click on counterbore. Then let's have a look at some of the options down here. So we've already talked about the standard that we're going to use, BSI. And then for a counterbore, what size of counterbore at the top are you going to require? So what fixing type do you intend to use in this hole? And this is on the type drop down here. So there's various different types of hexagon headed bolts that you can buy that all conform to BSI standard. And you can see there's a unified BS European standard number here, BSEN, and then a number after it. If you put that into Google, you'll get loads of bolts that appear to buy that conform to these standards. So yeah, hex bolt grade C, hex screw grade AB, blah, 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 blah. And as you select these, what it's doing is it's playing around with the size and depth of this counterbore to accommodate these different types of. So yeah, you saw down below there, because I've got custom sizing, you can see the scale of the hole changing when I select different options here. So yeah, that's all that's doing. So you match your hole to the fixing that you intend to use in that hole. So let's just pick one of these. It doesn't really matter. Let's have a hex socket head. So this would be a Allen key type bolt. So hex socket head is what we want to accommodate. M5, yeah, M5 will do for us. So it's a metric hole, and it's got clearance for an M5 bolt or an M5 screw to pass through. And then everything else, I don't think we'll play with these too much. So the fit, let's just have a quick look at that. So for an M5 bolt, you can have a hole that's got a very close fit, or the bolt is very tight in the hole. You can have a normal fit, which is what it says, or you can have a loose fit where you've got lots of clearance within this hole for the bolt to sort of move around in there. So normal is fine for us. We don't want to play with the sizing. We just want to leave it as the bog standard, BSI standard. So we'd probably deselect that. Don't show custom sizing. And then we've already said we want these bolt holes to pass through the whole thing. So I'll leave this on through all. That's fine. And then the rest, I don't think we'll play with at this point, but you can see there's lots and lots of other options. There's things to do with tolerancing as well. But yeah, we'll leave everything else. We've set up the major type of hole that we require. So the next tab at the top, so all of tab 1, or the type tab, is us defining what type of hole we want. Tab 2, as it says, is where do we want to put this hole? Or in our case, where do we want to put these 4 holes of that type? And when you click on there, it's basically asking you a question again. So it's highlighted in yellow, saying click on a face where you want to begin placing these holes. So in our case, it's the top face of our part. So this would be the face if, in our example, so imagine you were producing this plate on a CNC milling machine, or maybe even a pillar drill. So you'd cut the plate already into shape, and then you were ready to drill these holes through, or do the initial drilling operation for these holes. You would approach the plate, if you were the drilling head, from this side. You wouldn't approach it from the other side, because then you couldn't create the counterboard section. Or you could, but it would be very, very difficult to do. So yeah, this is what it's asking. It's saying which side are you going to approach your part from when you create these holes. So it's this top face that we're going to click on. So when I click on the top face, my system rotates my view round. And then all I'm going to do is I'm going to go up to near one of the corners where I want one of these holes, and I'm just going to click like that. So now I've got a single hole placed somewhere up in that corner. And if I use my middle button to just rotate my view back to a sort of 3D perspective, you can see what's happened. It's given me a preview of the counterboard head section and the through hole. So the, what was it? Clearance for an M4 bolt that's passing all the way through my block. And if I view it from the bottom side, you can see it is going to pass all the way through. Then what it's doing is it's offering me a second hole. And if I was to click again, I would drop a second hole on this block, and then so on and so on and so on and so on. So you can drop as many holes as you want of the type that you've specified in a single hole feature. So that's the first thing to note. But what I'm going to do, I'm not going to manually place the other 3 holes. I'm going to create them as mirrored copies of this one. So I don't want to create any more holes. So I'm going to hit escape. And then what you may not have noticed is the way that we're placing these holes within this special hole feature that we're creating is to simply create a sketch on this top plane, but all the sketch includes are points. It doesn't include any lines or rectangles or circles or anything else. We're just sketching points. So there's the point sketch tool. And the system only understands in this mode where there is a point, place a hole. That's it. That's all it's doing. But we're essentially in Sketcher. And that's why the sketch menu's active up here. The nice thing about that is we have actually got access to all the tools in here. And one of the tools, although I'm not sure that we've used it before, is the Mirror Sketch Entities tool up there. I think we may have used this once before. So if we click on Mirror Entities in the Sketch toolbar, if you had that point already selected like I did, so I still had the center point of that hole selected, the little point, it enters it into that box there. If you didn't, that box is waiting for some input. That's why it's highlighted in blue. So you would just click on the center point of that hole. So you can see it entered in there. Then what I'm going to do is tell the system, what do I want to mirror that about? What is the mirror in this mirror operation? So click on that second box, click on one of the planes, so that right plane will do for this one. And it gives me a preview of where that mirrored copy is going to end up. So it's going to end up over there. You can see the little yellow preview. I'm happy with that, so I'll click on tick on the mirror operation. Then I've got a mirrored copy. Now I'm just going to repeat that operation again. So I'm going to click on mirror entities. What entities do I want to mirror? I want to mirror the 2 center points now. So I'm clicking on both of them and they both appear in that entities box. Then again, I'm going to tell it what plane I want to use to mirror about. So I'll click on that mirror about box and then I'll pick the front plane this time. And then I get a preview again of what it's going to do, highlighted in yellow there, the little yellow spots. Click on OK. Now I've got my 4 center points for my holes. And if I just do a bit of investigation, so if I drag the original one around, you can see the mirrored copies follow it, because I've essentially put these relations in by using the mirror tool, and these relations are symmetric. So you can see as I hover over them, it highlights the plane that it's symmetrical about, and it highlights the 2 points that are symmetrical to each other. So you can see that. So it's just achieved that by putting some special type of relations in there. So I've got my points. So now what I'd do, if I was designing this part for real, I'd want to fully define their position, just like we do in any other sketch. So they're blue at the moment, they're free to move. That's no good. So I want to put some smart dimensions in. And how I would dimension these, I would either reference them to the base planes. That would be one way of dimensioning their horizontal and vertical positions. Or if I want their positions to kind of move with the block itself, I could reference them to the outer edges of the block, like that. Or I could do a combination of the 2. So maybe I'd do the horizontal dimension relative to the edge of the block, but then maybe do the vertical dimension relative to that base plane. it depends what you're trying to achieve with your design. Whether it's better for your design that they always be a set distance away from the edges, or whether they always be a set distance away from the center point of the block. Yeah, but let's dimension ours to the edge on this example. So that's 10 mil and 15 mil. And you can see I only have to put those in for this one point, and all the other 3 points become fully defined because of those symmetrical relationships. So let's say I'm happy now. I'm happy with that feature. I just click on the green tick like we do with all the others. And there you go. It's put the counterbores in. So a few things to note there with the hole feature and why you would use the hole feature instead of just using an extruded cut. So you could achieve exactly the same geometry as we've got here. So all this is it's a cylindrical cutaway there down to a depth, and then it's a second cylindrical cut. So you could achieve that with 2 extruded cuts. Both of the extruded cuts would contain just a circle sketch, and then the first one would extrude down to whatever that depth is, and then the second one would be centered around the first one, but it would go all the way through. But there's a few reasons why not to do it that way. First one is it's extra work. When you get proficient with this hole wizard feature, you get in there and you just click, 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 position, done, and you're out. So it's a time saver. And the second big sort of advantage of it is that within the design manager here, or the design tree, it actually lists the hole wizard features with the appropriate name for what they actually are. So you can see it's listed it as an M5 hex socket head cap accommodating hole, which is again quite a time saver. If you're a neat sort of part modeler within SolidWorks, and you do the right thing and you rename all your features so that they're easily referenced when you come back to them, then to type all that information in is a bit long-winded. So the system does that for you, gives them the appropriate name. So you can see at a glance, this is a counterbore for an M5. And more than that, it's for an M5 socket head, not an M5 hex head. So yeah, and all of that information about the hole and the standard that it adheres to can be put into a drawing really easily. So when you get hole features in drawings, you can get the system to automatically label them all up for you, but only if you use the hole wizard. If you just use an extruded cut, you won't get all that automation inside the drawing. So yeah, hole wizard, that's the way. If your holes in any way conform to any sort of standard, use the hole wizard to put them in. Don't just make them dumb features like extruded cuts or revolve cuts, or even modeling them into the actual the original extrude itself. It's much better to put them in as hole features. So yeah, there's a bit extra in there. I think in the tutorial, once we've set up the hole feature, we kind of drop back in and create a second copy of the plate. So if that is the component that's going to be bolted to something else, then that would be the second component that it gets bolted to. And you can see in that particular hole feature, we select the threaded hole, and you can kind of see a little representation of the thread there. So yeah, we might touch on that. In fact, I'm sure we will when we come to model up some more complicated parts. But I think that's about all the time for today. Yeah, I think we've got about 3 minutes left. So I think we'll sign off at that point. And yeah, we'll touch on the drawing stuff again, definitely. We'll just finish off the hole wizard, which will only take about 10-15 minutes just to have a look at how it behaves in the drawings. And then we'll kind of move on to something else next week. And I will endeavour to get the spec for you for the project as well. So there's a little spec sheet as to what you're expected to do. But the eagle-eyed of you may have already gone in here in the learning materials, and something like this looks very similar to the sorts of things that you're doing with Tarsum, I'm sure. So yeah, this has some bearing on the project work that we're going to do. So yeah, but I will turn up next week with all that spec, and you can have a look at it, and we'll have a chat about it. So yeah, if there's no other major questions, I'll probably sign off. Where are the recordings for these lectures? I've not had a chance to put them up yet, but a lot of the stuff that we're covering, if you drop into my big long YouTube list of SolidWorks tutorials there, a lot of it is covered in there already. But yeah, I'll try and make some time and upload these specific tutorials, but almost all of the content that we're covering is already up there. It's just chopped up into its own sort of headed sections there. So yeah, don't worry too much about that. A lot of it's already there. So yeah, has anyone got anything else, or shall we call it a day there? And I'll see you all next week. Yep, all good. Marvellous. Okay, bye then.